Hello and welcome back to the channel. Today we're going to investigate an overheating issue on this Jeep 2.8 CRD. The symptoms of the overheating are that if the vehicle is driven at high speed, either towing or under load or going up a hill, the engine will overheat. If driven below 50 miles an hour, generally it will not overheat, but if going at say 70 miles an hour up a hill with the air conditioning on, the temperature will rise, and if kept unchecked will get extremely hot and bring up a warning on the dashboard. The first thing that we need to do is strip off the engine cover and the cowl, and we're going to be looking at the viscous fan. I'll explain a little bit later in the video how the viscous fan and why I'm going down this route as my investigation. So I've removed the engine cover. The engine cover is held on by little ball joints there across the engine. You simply pull the cover off after removing the cap and the dipstick. I've removed the cowl as much as I can, and what we need to now do is remove the actual fan itself. As you can see, I've got a large spanner onto the fan. I just need to lock the mechanism and turn it in a anti-clockwise direction, and that will allow the fan to spin off, and the fan and the cowl will come off as one piece. So I've got the fan cowl off. It came off with the fan. It's located by two 10mm bolts there and there, and two tabs there and there, and they screwed into there and there, and there's a couple of tabs down the bottom there that the cowling went into. The way that I removed the fan was to put a screwdriver through this pulley to lock it, and then to use this spanner here to unscrew the main hub nut. So this is the fan unit removed from the vehicle. That's the back end that was screwed onto that pulley. And how this works is that at low engine speeds the fan rotates at a small percentage of the engine speed. So I'm not sure the exact figures, but say for example the engine is rotating at 1000 RPM, the viscous coupling will be allowing the fan to maybe rotate at 200 RPM. This reduces load on the engine and reduces fuel consumption, and when the engine speed picks up and the engine gets hot, this bimetallic mechanism here should expand, and it should open a valve in the centre of the viscous fan. So all of this will basically work in that it's located right in front of the radiator. As the radiator gets hot and the fan cowling keeps the air within the fan area, these fins get hot, this item gets hot, expands and opens the valve. That then creates a direct drive to the fan, so the fan will then run at 1000 RPM, for example when the engine is rotating at 1000 RPM. And as the engine cools down, the radiator will be controlled via the thermostat, reduce the engine temperature, and therefore this will start to contract again and close the valve off and reduce the speed and the load of the fan. So the problem on this vehicle, as you can see, is that this bimetallic mechanism is extremely rusty. The vehicle had been standing and only done 1000 miles in 1 year before I started using it, and I've already cleaned this up once, and when I did clean this up the overheating issue stopped, but at the time I was working and didn't use the vehicle to commute to work, so again it stood around for some time on a north facing drive which was fairly damp, as you can see. The sort of ground is quite damp and holds the water. This started to corrode, and it's better than it was, but I don't think that valve is getting the full range of movement. So what I'm going to do is I'm going to use some penetrating oil on this, and I'm going to operate the valve to free it off. So I've cleaned up the area around the bimetallic coil, and basically you get a pair of pliers down here and you just twist this valve like so. Should move nice and free. As you can see, this one is moving nice and freely now, so you can tell that is all freed off. I'll apply a little bit of grease just to protect the corrosion building up back on that bimetallic. I'll use a high temperature grease so that it won't spin off and make a whole mess with inside the engine bay. The other test you can do is you should be able to grip this nut and it shouldn't turn, so it'll turn easily anyway. So that is very stiff to turn, as you can see. So the fan is locking up. Essentially there should be some free movement so that when it's at idle it should be able to spin, but if that was really easy to move then there'd be a fault with the viscous fan itself. So I'll get that lubricated up and then we'll get that refitted. So it's all back together now. I've run it up and there's no nasty noises or anything. Just need to take it out on a road test and see whether that has fixed the problem. So we're out on a road test now. What we're going to do is head up Berry Hill. It's quite a steep hill. Haven't got a massive load on it, and temperature wise it's about 21 degrees today, so not a particularly hot day. But I put it in 4-wheel drive and I'm going to put the air conditioning on as well to create a bit more load on the vehicle. We're just going to see whether the temperature is going to rise going up the hill. Temperature is good. See, we're doing just over 60 miles an hour up this very steep hill. It would normally have caused the temperature to have gone up. On previous occasions it's got 3/4 up. It's never got into the red on this particular journey, but it does get high. So far we're keeping at dead centre. There we go. Like to say thank you for watching this video. If it's been useful for you, if you wouldn't mind liking and subscribing, it helps me to make more content.